You are standing on the surface of the earth. You feel your feet planted, your legs supporting your weight. You pick up an object and release it. It accelerates toward the floor. Everything in your body, every neuron shaped by a lifetime of experience, screams a single coherent story. There is a force here. A force is pulling that object down. A force is pressing you against the ground. This story is not just intuitive, it is codified. For centuries, we called it the force of gravity. Newton wrote it into his laws. We calculate with it, we engineer with it. The force of gravity between two masses. It is the cornerstone of our mental architecture. And according to the theory of general relativity that he helped make accessible, it is a complete fiction. To see why, you must perform a simple thought experiment. But you must perform it with absolute honesty, setting aside what you think you know. Imagine you are in a sealed box, a room with no windows. You are standing on the floor and you feel your weight. You drop a pen, it falls to the floor. Now imagine this box is not sitting on the ground but is out in the depths of space, far from any planet or star. It is completely weightless. But then, imagine a rocket engine is firmly attached to the bottom of this box. The engine ignites. It fires with a constant, perfect thrust. The box begins to accelerate smoothly, uniformly through the empty void. Let's say it accelerates at 98 meters per second squared. Now, what happens inside the box? You are floating in the middle of the room when the engine starts. What do you experience? The floor of the box begins to move upward toward you. From your perspective, you begin to move toward the floor. You meet it. You are now pressed against it. You stand up. You feel a force holding you to this floor. It feels indistinguishable from your weight on earth. You take a pen from your pocket and release it. Relative to you, the pen does not float. It accelerates downward, hitting the floor at exactly 988 millius-2. Every single experiment you could conduct inside this accelerating box, pendulum swinging, water pouring from a bottle. The tension in a spring scale would give results identical to those you'd get in a stationary box sitting on the surface of the earth. Einstein called this the principle of equivalence. It is not an analogy, it is a postulate of fundamental equality. There is no physical experiment you can do, locally, to tell the difference between being in a uniform gravitational field and being in a uniformly accelerating frame of reference. Now, hold that thought. Consider the pen you dropped in the accelerating box. From the perspective of someone outside, in the quiet, force-free void of space, what is happening to that pen? The box is accelerating upward. The pen, the moment you release it, is no longer being pushed by the box's wall or floor. According to Newton's first law, an object with no force on it continues in a state of uniform motion. So the pen continues moving at the constant velocity it had at the moment of release. It is inertial. It feels no force. But the floor of the box, driven by the rocket, is accelerating upward to meet it. From the outside, the pen is not being pulled down. It is simply continuing on its way while the floor races up to smash into it. According to the equivalence principle, the situation for that pen, locally, is identical to the pen in the accelerating box. Therefore, the conclusion must be the same. From a certain privileged perspective, the perspective of free fall, the pen is not feeling a force. It is simply following its natural path. The ground, like the floor of the accelerating box, is what is coming up to meet it. This is the first and most important intuition that must be destroyed. You think gravity is a force that acts on a falling object. It is not. A freely falling object experiences zero net force. It is weightless. An astronaut in orbit is not beyond Earth's gravity. They are in free fall around it, and they feel no force of gravity. They are, according to the physics, in an inertial state. The force you feel, the weight in your feet, is not the force of gravity pulling on you. It is the force of the ground pushing up on you, preventing you from following your natural force-free geodesic path. The very sensation we use to define gravity, the sensation of weight, is not the presence of a gravitational force. It is the presence of a force that opposes gravity. It is the force that stops you from falling. So, the very first thing you must accept is that your primary sensation is a lie. You do not feel the pull of the earth. You feel the earth pushing you away from the path you naturally want to take. Gravity, in its purest form, is not something you feel at all. It is the state of feeling nothing. What, then, is it? If it's not a force acting on a falling body, what is happening? It is a statement about the arena itself. And to see that, you must abandon the idea of a straight line. Your intuition has been given a single devastating crack. A falling object feels no force. The stage is now set for a deeper, more profound confusion. Because if gravity is not a force acting on objects, then what is governing their motion? Why do they move at all? Why does the pen, released from your hand, not simply hang in midair? The answer, the one that replaces the demolished concept of force, is geometry, but not the geometry you know. You have a deeply ingrained, almost sacred belief about the most natural state of motion. An object with no forces on it, you learned, moves in a straight line at constant speed. This idea is the cornerstone of Newtonian physics. It is also, in the context of gravity, completely and utterly false. It is false because your definition of a straight line is parochial. It is a straight line drawn on a flat Euclidean sheet of paper. It is the shortest distance between 2 points in an uncurved space. The universe, it turns out, is under no obligation to conform to this flatness. And when the arena is curved, the rules of the game change in the most fundamental way possible. Consider the surface of the Earth. Not the planet as a sphere in space, but just its two-dimensional surface. Your entire universe is this globe. You have no concept of up or down off the surface. Now, you wish to take the most direct, most natural path between two cities. You do not burrow through the planet. That dimension does not exist for you. You follow a great circle route, the analog of a straight line on a sphere. We call this a geodesic, the shortest path between 2 points within the curved geometry. From the perspective of a bird flying in three-dimensional space, your path is not straight. It curves along the surface of the sphere. But from your perspective, as the ant, you are not turning. You are not feeling a force pushing you left or right. You are simply following the straightest possible line your universe allows. Your straight line has been redefined by the curvature of your world. Now, lift this idea from the two-dimensional surface of a sphere to the four-dimensional fabric of spacetime. Spacetime is the unified arena of the universe, where the three dimensions of space and the one dimension of time are woven together. What Einstein discovered is that mass and energy do not exert a force within this arena. Instead, they warp it. They create curvature in the four-dimensional fabric of spacetime itself. An object in freefall, our pen, an orbiting satellite, a planet around the sun, is not being pulled. It is doing the only thing an object can do when no other forces, like electromagnetism or friction, are acting on it. It is following a geodesic. It is tracing the straightest possible line through the curved geometry of spacetime. From our narrow three-dimensional perspective, this geodesic looks like a curved path. We see the Earth attracting the pen in a parabolic arc. We see the moon perpetually falling around the Earth in a circle. But from the object's own perspective, and in the true geometry of spacetime, it is moving inertially. It is on its straight line. The curvature is not in its motion. The curvature is in the stage upon which it moves. This is the monumental shift. Newton said, "A planet moves in an elliptical orbit because a force from the sun acts on it, deflecting it from the straight line it would otherwise follow." Einstein says there is no force. The planet follows a straight line, a geodesic in a spacetime that is curved by the sun's presence. The ellipse is the straight line. Your old intuition that a straight line means the Euclidean line you learned in school was a prejudice born of living in a region of spacetime so flat that its curvature was imperceptible. It is the prejudice of a microbe living on a seemingly infinite flat tabletop, declaring all lines must be ruler straight, unaware the table is on the surface of a vast gentle hill, so the falling apple is not being pulled. It is, for the first moment of its release, completely free. And in its freedom, it simply obeys the most natural law of all. Objects follow the geometry of their universe. They go straight. But this raises a far more subtle and disconcerting question. We've spoken of curved spacetime. Your mind likely pictures a rubber sheet sagging under a weight, a spatial dent. This picture is dangerously incomplete. It misses the most crucial architect of the effect you feel as gravity. That architect is not space. It is time. A universe where straight is redefined by curvature. But your imagination, trained for a lifetime, is likely betraying you. You are picturing this curvature as a purely spatial phenomenon, a depression, a hill, a warp in the three-dimensional grid of the world, like a marble rolling in a bowl. This picture, while a step forward, is a profound oversimplification. It is wrong in a way that obscures the true engine of gravity. To find that engine, you must ask a more pointed question. In our geometric model, objects follow straight lines, geodesics in curved spacetime. Fine, but what, specifically, About this curvature causes two objects like the Earth and the apple to begin moving toward each other in the first place. If they are both simply following their own straight lines, why do those lines converge? The answer lies not in the bending of space, but in the bending of time. Consider the most famous consequence of Einstein's earlier theory, special relativity. Time runs at different rates for observers in different states of motion or in different gravitational potentials. A clock at a high altitude ticks slightly faster than an identical clock at sea level. This is not a theory, it is a measured fact, confirmed by extraordinarily precise atomic clocks. The difference is tiny on Earth, but it is real. Time itself flows at different speeds depending on where you are in a gravitational field. Now, connect this to the geometric picture. In space-time, motion is not just through space, it is through time as well. You are right now moving relentlessly into the future. Your velocity through time is, in a very real sense, the most fundamental velocity you have. In the flat space-time of special relativity, objects at rest relative to each other move along parallel time axes. Their futures are aligned. But in the curved space-time near a planet, the curvature caused by mass is not symmetric. The warping of the time dimension is vastly more significant than the warping of the three space dimensions. Here is the critical, non-intuitive leap. The primary manifestation of gravity, the thing that makes objects fall, is the gradient in the flow of time. Imagine two particles initially at rest with respect to each other, suspended in the gravitational field of the Earth. One is slightly higher than the other. According to general relativity, they are not simply sitting in a curved space. They are both moving forward through time along their world lines at the speed of 1 second per second from their own perspectives. However, because time flows faster for the higher particle, its future is tilted relative to the future of the lower particle. In the space-time geometry, remaining at rest in space is not a straight line. In fact, to hover at a constant altitude, you must constantly accelerate, burning fuel, fighting against the geodesic. The true straight line, the geodesic, is the one where you maximize your proper time, your own experience time between two events. And the path that maximizes your proper time in a region where time runs slower deeper in the gravity well is, paradoxically, to begin moving spatially toward that slower time region. Think of it this way: the particle wants to age as slowly as possible relative to the cosmic clock. It seeks the path where its own clock ticks the slowest compared to all other possible paths between two events. The deepest part of the gravitational well is where time is slowest. Therefore, the geodesic, the path of maximal proper time, is one that dips downward, trading spatial position for a more advantageous rate of time flow. The falling apple is not being pulled spatially, it is, in a sense, sliding down a hill of time. Its trajectory is a direct result of time flowing at different rates at its stem and its tip. The spatial motion, the fall, is a secondary effect, a consequence of the relentless, inexorable drive of all objects to follow paths that maximize their proper time in a curved time landscape. This is why the rubber sheet model is a dangerous crutch. It depicts gravity as a spatial slope, where objects roll down like marbles. But in reality, for planetary orbits and falling apples, over 99% of the curvature effect that determines their path is in the time component of spacetime, not the spatial components. The marble is not rolling down a spatial hill, it is being steered by a gradient in the very rate of its existence. You feel this every second. The force pressing you against the ground is what you experience because you are being prevented from following the geodesic that time's curvature has laid out for you. Your feet are in a region of slower time than your head. Your natural force-free path is to let your head catch up to your feet by moving downward. The ground stops you, and you feel that as weight. So, the architect of what you call gravity is not an invisible hand in space. It is a silent, invisible gradient in the tempo of reality itself. Mass doesn't bend space much, it primarily bends time. And we fall, not because we are pulled, but because we are navigating that temporal landscape. This realization leads to an uncomfortable dissonance. Your body's most trusted sensor, your sense of pressure, of weight, is now exposed as an interpreter of a complex illusion. It is time to interrogate that sensor directly. Your body is a liar. It has been lying to you about gravity from the moment you first stood up. The sensation you call weight, the pressure in your soles, the tension in your muscles, the very feeling of being anchored, is not a report from the frontier of a fundamental force. It is the sensation of a prison wall. To understand this betrayal, you must make a distinction that your nervous system is evolutionarily incapable of making. It is the distinction between proper acceleration and coordinate acceleration. Coordinate acceleration is a bookkeeping entry. It is a change in velocity recorded on a map relative to a chosen, often arbitrary, reference frame. But from the perspective of the pen itself, from its own local frame of reference, nothing is changing. It feels nothing. Its accelerometer, a device that measures proper acceleration, reads 0. Proper acceleration is different. It is not a coordinate on a map. It is an objective, physical experience. It is the feeling of being pushed, stretched, or compressed. It is the reading on an accelerometer. It is the force you feel when a car speeds up, when an elevator lurches upward, or when a rocket engine fires. Critically, proper acceleration is what you feel when you are not following a geodesic. It is the sensation of your path being forced away from the straightest possible line in space-time. Now, stand on a bathroom scale. The number you see is not a measure of the gravitational force on you. It is a measure of the force the scale must exert upward to stop you from following your natural, force-free geodesic into the Earth. The scale is not measuring gravity, it is measuring the force that opposes gravity. It measures your proper acceleration, which, while standing still on Earth, is 9-8 miles to upward, away from the center of the planet. This is the core of the propaganda. Your brain, in a monumental act of perceptual reinterpretation, takes the signal, "the floor is pushing up on my feet with great force," and inverts it to create the intuitive model, "I am being pulled down." But it has poisoned our fundamental understanding of motion. It has made us believe the lie that a force is acting on a stationary object. In reality, a stationary object on Earth is undergoing constant proper acceleration. It is, every second, being blasted upward by the rigid resistance of the ground, like a rocket whose engine is the electromagnetic repulsion between the atoms of your shoes and the atoms of the floor. Contrast this with an astronaut in the International Space Station. They are weightless. Their scale would read 0. According to your old intuition, this is because they are beyond Earth's gravity. This is false. The Earth's gravity at that altitude is almost as strong as it is on the surface. The astronaut is weightless because they, and their scale, are in freefall. They are following a geodesic. Their proper acceleration is 0. They are, for the first time, experiencing the true, unforced state of motion under gravity, nothing, no pull, no weight, just a quiet, straight-line drift through curved space-time. The force, you see, is the artifact of interruption. It is the sensation of being prevented from falling. Your entire life, you have been in a state of constant interruption. You have never felt gravity. You have only ever felt the absence of its consequence. This is why the equivalence principle is so powerful and so disorienting. In the accelerating rocket ship in deep space, you feel a force because you are genuinely accelerating. Your proper acceleration is non-zero. On Earth, you feel an identical force, not because you are accelerating upward, but because the ground is perpetually interrupting your geodesic. The physical sensation is identical because the physical condition of non-zero proper acceleration is identical. The cause of that proper acceleration is different, but the local experience is not.